Boats and engines. Can't remember the rest. What was it?
This is part 12 of a build.
12 of the build. Don't use that.
So just doing the RCD compliance testing just in the lake, and this is one of the tests, which is twice the load capacity. I've actually done a fair bit more, so I've put in, you need 75 kilograms per person loaded on one side, so I've done 200 kilograms loaded on one side, and it's still got over 300 mil of freeboard on the leany side. It's good. Just got to measure the angle now and see what that is, but I think it's allowed 26 degrees or 30 degrees, and it's way less than that. I think it's about 10, but we'll measure it and see. Still plenty of freeboard. Quite when you'd have that's the equivalent of 2 15-stone people standing right on the edge. Quite when you'd need that level of stability, I don't know, but it seems okay. So I managed to pass all the RCD tests absolutely fine. It's sort of well within the margins for category C, that is. Just get some first pictures on the water. I can't actually drive the boat here because it's a sailing lake, but they very kindly let me do my tests here, so thank you very much, Spinnaker Lake, Spinnaker Club. Have a look at their website. I think it's just spinnakerclub.co.uk. It's got the first pictures of her actually underwater. She looks nice. Still no seats yet. Soon. This is the next part of the stability testing for the RCD compliance, and I'm about to sink the boat. So what I have to do is, got the fake outboard there, I'll fill that up with 125 kilos of sand, so 5 bags of sand, and then I have to try and push the lowest point of freeboard 100 millimeters under the surface of the water, and hold it like that for 5 minutes until it stabilises. Then after that I have to apply a weight, or have one fat man like myself stand on each 1/3 corner and make sure it's stable when the boat's fully flooded. Now this, I think, is a slightly odd way of testing it. It should be really flooded by volume of a boat, because if you were to have like an open top rowing boat and you push down the sides 100 mil under the water, it would just scoop up a little bit because you wouldn't have to push it down very far or very hard for it to go, let it go, and it would only be say 10 or 15% full of water. Whereas on this boat, which is almost totally closed top, so far less prone to swamping, it will be filled a lot more than 10%. So although it's inherently less likely to flood, it has to be dealt with much harder testing, and that's down to the whoever wrote the ISO standards, which I'm having some issues with them because a lot of it really doesn't make sense. But then I understand it's got to be tested for safety. If you're going to try and sell something like this, you have to cover yourself for one thing and make sure it is a safe product. So what I've done is I've just taken the wheels off a trailer, jacked up that end a little bit, so see if I can slide it in. I might not be able to. I might have to get a guy from next door with a what you call them, big telehandler, forklifty thing to lift it in, but I'll see if I can straggle it in without the I've taken all the outboard weight out, so it doesn't weigh very much, so I should be able to get it in. It's just might not be able to get it back out again. There's a new car, little Jimny, pretty cool. I know a lot of you liked my old big Hilux, but it's a lot more economical and more modern, so I can actually drive it on the motorway, whereas the Hilux with its big wheels is a nightmare. So yeah, I'm not going to film struggling trying to get it in, or film it when I'm sinking it. I'm sure you'll all enjoy that. Right, so I managed to get her off the trailer into the water. It was surprisingly easy, just lifted the front end and pushed, and in she went. So now I'm going to flood it. Once I've done that, I'll show you some pictures of it nicely full of water, and then start doing the stability tests. One nice thing about the RCD, or the recreational craft directive, is it's got a lot of complicated stuff with dangling weights at certain points, and the points happen to be about where the cleats are, but it also says that if you're fat like myself, you can just stand on the four corners, so I will be doing that. So I'll probably put the weights in the back first so it's easier to push down, and then start flooding. Right, it took some doing, but I've got it flooded. There's a lot of water in it, as you can see. I reckon there's over a cubic metre, so over a tonne in there. Because the floors are all sloped back and stepped, it all drains nicely into the transom though. So in reality, there's no way this much water could get into it, but if it did, it's straight to the back, and the bilge pump will pump it out because it's got an auto pump. But I'm going to slacken off the lines now so there's nothing stabilising it, then try standing on the 4 points. I'll get somebody else to take some pictures while I'm doing it, just for my compliance documents. Can't really see how much water in there is. Can you see the line? It's a lot. Yeah, up to there. So the next stage of the ISO testing, that is the RCD compliance, or recreational craft directive. That's what we've sort of been going through in this episode. So before, you saw me testing for stability, and they're quite nice practical tests. Here, this is the Scantling calculation, so that's testing the testing whether it's structurally adequate. So this is based on ISO 12215-5. The -5 bit just means it's for, I think it was small boats, motorboats under 6 meters, and there's different -1, 2, 3, 4, etc. for sailing boats or whatever, or boats over 6 meters, whatever type of boat it is. And when you buy this ISO, then you can download this Excel based bit of software for free, and it helps you to just go through and calculate whether or not you do comply with the EU regulations. So to start off with, you just enter in your basic boat information, so length of hull, length of waterline, beam of hull, beam of waterline, BC, not sure, can't remember, TC, so that must be what it draws, total depth of hull, angle of dead rise, loaded weight, and design speed and design category. So category C is for inshore waters. It's up to a certain wave height, I can't remember what, but it's all in the regulations. And then it calculates, based on the speed, roughly what pressures are going to be enforced on the hull. And from that you can you basically break up the hull into panels separated by your stiffeners, and then it calculates how thick the stiffeners need to be and how thick the layup actually needs to be as well. So once you've got all your basic information loaded, then you go to a materials list, and you can put in the materials that you're using. I've actually repeated myself, because when I did it I thought you put in actually the layup you're using. I only needed to put in that once, and that once, and then obviously the plywood used and the stringers, and for my boat that's all I needed to do. Obviously if you had more materials or sandwich constructions, see here, you can put it in, and it covers pretty much anything imaginable, certainly with a composite boat. And then from here you go to what's called a central zone, and in this you can do the scantling calculations for the individual parts of the boat. So you've got the hull, the sides, the decks, the wheelhouse if you had one. So we'll just look at the hull, and you can see we're sort of broken up into cross sections, and it calls them panels. That's for stiffeners, this is for panels. And then you can enter in, say, the information for, so that's the layup we used in the hull, and based on panel size it tells you how much you actually needed. So they reckon it needs to be 7mm thick, and how many grams of chop strand mat it needs to meet robustness. So according to this, it's here, so it says it's twice as much glass as it needs to be, and it's the thickness it needs to be just to pass. Now a point I should make is it's nice that somebody's done this. I think it was Southampton University. It's cool that they've done this, and it's free when you get the ISO in it. Oh, sorry, just bashed the microphone. And it helps out a lot. It does not guarantee that it's going to be structurally sound. It guarantees you pass the EU regulations. So when I designed the boat, obviously it was all done in CAD, so I used finite element analysis, which really takes the shape of a boat into account, and this does to some extent. You can put in curvatures and stuff, but according to finite element analysis, this should be about 4.6mm thick, and that's with that was me really overloading it, so it doesn't even need to be that thick. So on this point on the hull, it's really erring on the side of caution, and I have laid it up to comply with this, just so I comply with the EU regulations, but it's doesn't necessarily have that much to do with safety. And I'll show you something else which is slightly worrying, which is if you go to, so I'll go back again, go to central zone and look at the deck, go to thickness. It thinks that to be safe it needs to have 0.96mm, so it's saying it needs to be under a millimetre thick. Now if the deck was under a millimetre thick, it would comply with the regulations, but if you jumped up and down on it, you go straight through it. So don't take this as being ultimately safe. Either use a bit of common sense, or a much better method is to use finite element analysis and get some real scientific data about the stresses involved and how thick it really needs to be.
So you can see here on when you go through, if it was too thin, then it will just come up with fail. So it's a nice easy way to make sure that you do comply with regulations. Go to deck zone, I'll go back to central zone, go back to the hull again, and also you see you can put in the dimensions of the stiffeners you've used and how much glass you've put over them, and then again it gives you whether or not it passes for the EU regulations. So once you've gone through and done all that, right turn here, then you can go to, so you're going to spend quite a lot of time calculating the size of the panels, the size of your stiffeners, all of that. Once it's all done and entered, then you go to write report, and you can just open a document. It says open Word, but you can copy and paste it into sort of Paint or whatever you like, and you just copy and paste for all the components you use. You might not do all of these because obviously there's no deck house on this, so I missed out quite a few because obviously they're not here, and then it gives you a report a bit like that. I'll show you the report in a second, which you can use to get your RCD compliance. So on the RYA website there's information about how you go about this. You can either use a notified body, which is obviously going to cost you a lot of money, or you can self-certify on certain boats, but there's a nice little block diagram telling you, go away, nice little block diagram telling you whether or not you can.
So what we've got here is the report that I've generated. So this is the whole lot. This will be sent off to the British Marine Federation, and hopefully they will give me a manufacturer's code, and from there that means that I can put a CE mark on the boat with its serial number, its crew loading, manufacturer number, which is what I need from this report, and a few other little bits of information. So this is the report generated from the Scantling calculations which you just saw. So for each sort of component of a boat, each part and the stiffeners and everything else, sides, it sort of shows whether or not it passes. And I just put in a note about my findings with this software, but probably shouldn't have done. So, oh, it's going to be slow. So I don't know if I mentioned earlier, you've got to, if you're trying to sell into the EU, and this actually covers EU boats being exported to America, they've got their own set of regulations, but they're I'd say a bit more sensible than ours, but it does cover us over there. You'll need to download an awful lot of ISOs and read through them all, and they're not cheap. They're about £150 each, and I think for the ones that I have to comply with, there's probably 5 or 6. So you're looking at sort of, well, close to £1,000 just on ISO documents. Another point worth noting with the ISO stuff is you can download them, get them for free at any UK library by law. However, you won't get them in small libraries. It has to be sort of big city libraries in reality, although they're all supposed to have them. You can't take it out of a library, you can't photocopy it or photograph it, but you can take notes from it. I would suggest that there's so much you have to read through carefully, just buy them and
then you've got them there to look back at for reference, and you will need to, because there's a lot of information to read through. And so this is all the basically the stability stuff. So the tests that I showed you before, all this, I don't know if it's the I think it's just my computer being slow and not loading the PDF, but there's sort of pictures of what was going on earlier in the video, and all the different load tests. Yeah, measuring the angle of heel. So I think it was allowed to heel like 28 degrees, and that was 9.8 degrees. Sorry, that's upside down. And when you get in it, a 10-degree heel angle, it doesn't sound like a lot, but it is. It's leant right over. So some of the other tests I showed you earlier. So this is heel due to wind action. So basically it's just a calculation using the CAD model, just proving it's not a sailing boat, basically. So just saying I don't have to comply with that bit of the regulation. So if you had a big slab-sided motorboat, it's still kind of classed as a sailboat. It's like a ratio of how much is in the water compared to how much visible or windage surface area there is. Here's the ground sinking, which you just witnessed. And you can see, obviously I took all the interior out for that. I've now got to put it all back together so that we can actually do some real testing. You can see down there the simulated outboard. So obviously I didn't know what was going to happen entirely. I didn't want to risk capsizing it or sinking the outboard and ruining it, so I used the weights instead. And obviously took all the carpet out first. Don't I look gormless? So that's proving that you can bail it with a bucket, which you can, and the mighty bilge pump, which you saw earlier. So this is all part of, I won't go back up, but one of the ISOs. The ISOs to do with safety. Not safety, stability, sorry. And now we get on to visibility. Again, you could, if you didn't have a CAD model, you could just draw out the side of your boat and plot it out on a piece of paper. Lucky on CAD I can just draw a couple of lines in a few seconds and it tells me the angles of visibility. It's got almost 360 degree visibility, unless you had a tool like outboard like I have. So I've just put in a segment of no visibility behind the boat there, where the outboard would be a bit bigger than it needs to be, but it's got more visibility than it needs to. Protection from falling overboard, because it's classed as a high speed craft, that's anything which goes above 25 knots, which is probably about 28 miles an hour. Don't know in kilometres an hour. It needs to have some sort of rigid support, body support they call it, around the driver. And sorry, someone just came in. And that's these bits here. That's a rigid support for sides, and also it's got bucket seats in it, so that holds you down as well, and some method of reboarding. Engine insulation, there's no, because it's outboard, there's no ISO covering it, but they just say you need to obviously fit it in accordance with the manufacturer's specification, and of course it needs a kill cord and a neutral safety switch, which my outboard didn't have a kill cord, but I put that onto the controller retrospectively and it did have neutral safety. Again, electrical systems, there's almost none in the boat, and they're just 12 volt, so there is quite involved ISOs according to this, but the electrical system in the boat is just the ray marine and the bilge pump pretty much, and they're both fused and fitted with the according to the manufacturer's recommendations. Fire protection, again, there's a huge amount of ISO information involving this. As it happens, because of the funny way it's all classified, it's classified as an open boat even though it's not. It's got a portable fuel tank. If it was just that bit, it wouldn't need any fire protection at all, as in no fire extinguisher, because the outboard's above 25 kilowatts. It needs I can't remember that's what I fitted with, a 600 gram dry powder, but it tells you the specs that it needs. I think it needs an 8B class 8C or something, and you have fun digging up all the fire codings for that. So that's the document. I've got a couple of spelling mistakes to sort out. I kept calling minutes minutes or minuets or something. Minuets, yeah, because I can't spell. I just got to change that. Then I'm going to, what a pretty face, then I'm going to send it off to the British Marine Federation, and hopefully they'll come back with my manufacturer code so I can sell this boat. And if anybody wants to buy one, I guess if you're watching this far you're more interested in building your own boat though, that's fine. So yeah, hopefully they come back with it, my manufacturer code, and then I can start selling them. So I'll just see if I can find out that ISO number for you, just in case somebody else is trying to do this. So that's different, just to do with hatches. So yeah, it's ISO 11217-3, stability for boats under 6 meters, and it's quite a long document, but obviously this is very important, and it varies as to what category you're going for. I'm going for category C, so that's inshore waters, although there's category D, which is one lower, which I think is just sort of river use. And then there's the higher ones, which is A and B, and they're for pretty serious boats. I don't think, there's no way this would pass for category B, or certainly I think category A's ocean going, category B's probably far offshore. So there we have it. Sorry we didn't actually drive a boat today. I do actually have to do one more test, but I'll do that when we're filming it underwater. So now I'm going to go and start putting her all back together. Then hopefully we'll have a gap in the weather next week, and get you some nice videos of it underwater. I've got a new little action cam which I can fit to the boat, so we'll have some onboard footage. And then hopefully I'm going to get a mate out. He's got one of those fancy what they call Mavic drones, and get some cool video of it going. So yeah, thanks very much for watching guys, and see you later. Bye.